we would model a many-to-many. Now, in many-to-many, here we have an example of an association class here that presumably is adding a couple more fields here, right? That describe this association, this relationship between a student and a section, where a student might be enrolled in many sections, and a section might have many students enrolled in that one section. The enrollment might capture other fields, such as the grade that particular student got when they were enrolled in that section, any feedback that student might have provided when they were enrolled in that particular section. So in relational database, there's only one way to implement this, right? The only way to implement it is to have 3 different tables, right? You have one table for the student, one table for the section records, one table for the enrollments, where the enrollments would have those fields, right? Plus foreign keys that go out to the primary key in the student and a foreign key from the enrollment to the section. That's the only way to implement it in a relational database. In a non-relational database such as Mongo, you could still do that, right? You could still have the option of doing that, but you have many more options, right? You have many more ways of implementing the same thing. You could still do the classical way, where a particular document, like an enrollment, a particular enrollment, would have a field section whose value is some ID of some other record, right? Foreign key. Right, so this would be holding a foreign key whose value is the primary key of some other record. That's the classical way of doing it, right? So again, and then it would have another field where the student has a primary key, a foreign key that references the primary key of some other record. So you can still use the same technique that is available to you in relational databases, right? But you can instead do the following. Instead of doing that, you could, because these are objects, right? The fields in a relational database, the field can only have a value of a primitive data type, right? It could be an integer, a varchar, and so it cannot contain anything. Well, unless it's a blob, maybe. But typically it's just values, right? No objects. But here, because it's because this is an object database, the fields themselves can be fairly complex, right? It could be an array, it could be an object, it could be a more complex object. Here, it could be an array of IDs, right? It could be an IDs of all the sections that this particular student is enrolled in, right? So a particular student knows the sections that they are enrolled in. I'm enrolled in section 1, section 2, and so on and so forth. And the reverse is also true. I could say that a particular section knows about all the students that are enrolled in that particular section, right? So here's the student 1, student 2, and so on and so forth. Okay. The problem with this implementation has 2 drawbacks. One of the drawbacks is that notice that there's no place to put any feedback that a particular student might have had for a particular section. There's no place to put it. Okay. Or the particular grade that a particular student had, right? So somewhere we would have to capture that, right? There's no place to capture that here. The other drawback, which is even worse, is that here we have some redundancy here, right? We're capturing this information twice. The fact that a particular student is enrolled in a particular section is being captured in 2 places, right? The student knows what section they're enrolled in, but the section also knows which student is also enrolled in that section, right? So they're kind of like pointing to each other, right? So we're capturing the same information twice, right? Now this might be okay if you're not managing this relationship, right? If you have some automated mechanism that manages this bidirectional relationship, it's okay, right? Maybe at the application level you handle that, right? But if you're doing that programmatically yourself, that'd be very dangerous, right? It'd be very easily, you might be, the problem is that you have to, if you update one, you also have to update the other. And typically in databases, that's a no-no, right? If you're doing any updates, the update should be a single update, right? You shouldn't have to update, 2 records, right? And here you would have to, right? If a student is enrolled in a section, I need to update this array, telling the student which section they're enrolled in. But I need to also update the section letting know that this new student is enrolled in that section. Right? So that would be unfortunate. But nevertheless, it's an option. This might make more sense if it's a one-to-many relationship as opposed to a many-to-many relationship. And a one-to-many relationship would be okay, right? Where you have, if you have, I don't know, if you have only the students know the sections, then it would be okay because you only have one update to make, not two. Okay. So in a many-to-many, this is the classical way, which is still supported in Mongo, where you have an enrollment collection pointing to saying that that particular student is enrolled in that particular section. Okay? But you have the option, the second option. Here we have an enrollment table. Wait, do we have a student here? I guess we do, right? We have these are students, and I think we have sections, don't we? We do. So we could do some enrollments here, right? We could say db.enrollment enrollments .insert, and we can say that student, this particular student, is enrolled in this particular section. There we have it, right? We have an enrollment. Right? So if we say db.enrollments.find, we know that that particular student is enrolled in that particular section. The other alternative is to have each student document to have an array of sections, right? Section 1, section, and so on and so forth, pointing to the different sections that they're enrolled. But this would have to be a mirror image, right? It would have to look exactly the same way from the other end, right? Where the sections know which student are enrolled in those sections. Okay. So again, we can enroll another student. Let's see. We can say so here the students db.user.find whose type is student. Those two students. Notice that the students don't know anything about the sections, but we could update John and say that John is actually. Let's update John. So this would be db.user.update, and we're going to update the user whose ID is equal to this particular user. Close that. We're going to set the sections. Set the sections. Oops. My copy is not working. Copy. Sections is equal to that other section. Let's see, where do we have the sections? So we'll enroll them in that section. Oops. Section is an array, and it's going to have just one section. Let's close that. Close that. I think that's it. All right. So if we describe the students again, notice that now we have John knows about that particular section. If we want to enroll John in another section, let's get more sections. I forget the sections that find. Let's enroll them in another section. What we could do is update John again. Let's go up there. A user update. Instead of set, what we can do is push. We can push another section in there. We can say push into the array of sections. Oops. Push into sections. Push another value here. Let's close that. Let's look at John again. Now John has two sections in there, right? It's enrolled in, wait, did I enroll him in the same section? Oh no, they're different. Yeah, different sections, right? So yeah, so you can update, and also that gives a chance to introduce the fact that You can initialize an array. You can push elements into an existing array, which is pretty cool. But you would have to make sure that this is bidirectional, right? That if the students know about the section should also know about the students. So that's the only inconvenience, right? That this is not automatic. Even in JPA, it's not automatic, right? In Java, you're responsible if you have two that are referencing each other. You're also responsible for maintaining the bidirectionality of the two, right? So that's why we try to stay away from this. All right, so let's talk about one-to-many.